G'day everyone and welcome back to part 2 of Containers in Azure with Yas, and Yas is going to take us off with Web Apps with Containers, Azure Batch and Batch, Shipyard and Service Fabric. Yas, over to you.
Thanks, George. Welcome back everybody to part 2 of Containers in Azure. We sort of have a short introduction to the history, to Azure Container Registry and Azure Container Instances, and we saw how we can push an image into Azure and run it really easy and with really high speed in the Azure Container Instances. But our requirements and our customer requirements are not that simple all the time. So we need more services to run these containers simply depending on different features that the customers have in mind or based on their requirements. The next service I'm going to introduce to you is Web Apps. So our app services also support running a Docker container within them instead of publishing the application based on code. So if you have a web application in Azure, you definitely have the ability to point that to an Azure Container Registry and say, I want to run a container within this app, and the app will run the container. And the benefit of that compared to the Azure Container Instances is that you get to leverage all the benefits of the app services. So you get to leverage the custom domains, you get to leverage the auto scaling rules, you get to leverage the VNet integration. If you wanted to talk to your on-premises environment, you get to leverage the hybrid connector and a whole bunch of different features in the Azure Web Apps. So the good thing about this is that you can put that as part of your CI/CD pipeline. Azure Web Apps already has a new deployment center where it enables you to configure running a container within both from a Azure Container Registry or from an external image provider such as Docker Hub. And you can enable the continuous integration. So whenever a new version or a new tag of that image is available, Azure Web Apps automatically pulls that new image and runs the app based on that image. Obviously, depending on the type of tags that you have specified. So if you have specified a single tag such as V1, that's always going to be V1. If you push a new version to the V1, it will then pull and run it. But if you push V2, it will not update it unless you have specified, for example, a latest tag, which then in turn grabs the latest always. Similar to what we had with the ACI that we saw before, the same happens with the Azure Web Apps. Now, if you wanted to have a look at some use cases for running container within Web Apps, you host your container as Web Apps on Azure, and you leverage all the features of the Azure App Services. If you need auto scaling or load balancing within multiple versions of your app, whether they're running in a container or whether they're running in multiple different containers, again, Azure Web Apps is really good for those particular scenarios. If you have specified, for example, you want multiple instances behind your app service, then definitely that will deploy the Docker image multiple on those instances as well, and you leverage the default load balancing rules there, which is great. Deploying in seconds into Azure. Integration with Azure App Services is super compared to other services. So you have, for example, GitHub Actions, you have Azure DevOps tasks, and you have local deployments from local Git or your local environment based on Visual Studio Code. So there are numerous different ways of publishing your web apps into Azure App Services, and that's what really gives this service an advantage over the other services. And the other fact is that you can deploy your web apps in a high availability architecture where the application is deployed, for example, in multiple different regions, and you have something, for example, like traffic manager profile, which distributes the load between which instances are available. So in those cases, again, this service is really great. This is great for your production environments, and if you have a high workload, definitely this service works for you. The only thing is that, again, there is no orchestration when it comes to running your containers in the Azure App Service. And the integration with monitoring solutions, Azure Application Insight, and also the analytics workspace and all the logs that are gathered automatically from your application, it really makes it a great candidate to run your containers within the service if you wanted to have extensive monitoring and log analytics accessible from your containers. So these are really great. If you wanted to have a look at how we can deploy and simply a app service into this amazing service, again, I want to bring you this particular script where we have our variables here defined. So these are the location, the name of the resource group, name of the web app, which should be again unique because it gives you a URL to access that. So it's a publicly accessible DNS name, and your app service plan name. So you create your Azure resource group. I already have that, so I don't want to do that. Next thing you need to run is creating your app service plan. The best type of app service plan to run your containers are Linux containers, Linux operating system, but you also have the ability to run your containers within Windows as well. So let's create an app service plan inside our resource group. We created a standard one app service plan with a Linux operating system. And we have specified the number of workers to be 1. So we don't want to make it complex. Again, we need to have the password for the ACR or Container Registry. And all we need to do is running that web application, creating that web application, give it the complete URL of the image. So that's your ACR name, azure.cr.io, and the image and the tag, and your username and password. What this does for you is that it creates a new instance of the web application. It will then add a bunch of configuration or application configuration with the URL of the your ACR with the username and the password, and that will automatically enable that automatic deployment inside your Azure service. So if I bring my Azure portal up again, come into my resource group, there should be a new web application deploy here. And this application already, if I come to the deployment center, this application already should have those properties here populated for us. So this is a single container. This is coming from Azure Container Registry. This is our registry with the image and the v1. And if I have a look at the configuration part of this app, you can see that there are a bunch of variables defined here, and the value of these variables are exactly the URL of the ACR, the username, and the password that we have specified. Now, all you need to do here is, for example, go and browse this app, or if you wanted to, for example, let's see. Okay, so this is still in progress because it needs to pull the image, and you can see all the logs from your container. So here you can see that the image pull has failed for whatever reason, because you might probably have missed the credentials part or something like that. But if pulling the image from the ACR, it takes a bit of a time to pull the image and run it. We probably need to skip this part to get to the other sections. We can come back to this and fix it later. I don't want to make more time, but this is a really great way for you to run. And you saw that we only need a few commands to get our application up and running. You can also come from the Azure portal and come to the deployment center and enable your settings or based on your container registry here as well. So you can enable, for example, your continuous deployment. You can come here and enable a system assigned identity, for example, or a user assigned identity, and then you can give access to that ACR instance from this system assigned identity and specify that you want to use the system assigned identity instead of the username and password that we hard coded in the configuration. So this is a much better way because it eliminates the need for using a username and password to run your containers within the service. But again, you can definitely leverage all the other properties of this amazing service when you're trying to run your containers. All right. So the next service we're going to review is the Azure Batch and Batch Shipyard. Not all the applications that you want to run as containers are front-end applications. So sometimes you might have a task, a batch job, which needs to be running in Azure, but you have some sort of a requirement from your on-premises environment that you can't simply use one of the existing Azure services to run that batch job. Whether it's requiring a few dependencies that you only need, that you only can achieve using a container, or whether simply you want to run these in a much sort of cost-efficient way compared to running those in those other services that do not leverage the power of containers. For that, Azure Batch offers a new service which is called Batch Shipyard. Batch Shipyard allows you to run multiple containers which host the same image, and then distribute the load within those containers to run a particularly long-running task for you inside those containers. You can leverage the Batch Shipyard dashboard to sort of have a look at all the different containers that are running, their memory usage, their CPU usage, and the status of like however they are at the moment going. You can scale this batch ship and add more nodes to it as you go on, or you can scale it out or scale it in based on the workload that are running inside the Azure Batch Shipyard. So really great service in order for you to run multiple long-running tasks, or even distribute a task or break it down into smaller ones and run it within the service. Some of the use cases for the Azure Batch and Batch Shipyard: if you have, for example, big data workloads, this is a great way for you to do your processing on those particular workloads. If you have, for example, reports, let's say you have a nightly report from your environment, or from whatever it might be, your finance, your IT, whatever it might be. You can run those reports on a night or on a scheduled basis within the Batch Shipyard, and those could be running within containers. So instead of running it as a standalone service which has a lot of dependencies, you can pack all of those dependencies into a container and run that within containers. If you have long-running tasks that take quite a while to finish, and you didn't want to, for example, use or leverage either Azure Batch itself or the web jobs which is offered through the app services, simply because of the limitations that those services might cause for your requirement, you can leverage this service and run those in a container as well. If you have CPU intensive processes, again, this is great because you can distribute the workload within many different containers and get your results back. And that's about it. I don't have any demos for Batch Shipyard. If you wanted to have a look at the Batch Shipyard and its offering, go into the Batch Shipyard page in Azure and have a look at all the different services that are there. How are we doing in terms of the time? I think we should be able to.
We're just fine, mate. Still got plenty of time for Service Fabric if you want to cover that as well in this video.
Cool. So the next service that we will cover is the Service Fabric. Service Fabric is a really advanced offering in Azure, which not only allows you to run your microservices in Azure or on your on-premises for that matter, but it also allows you to integrate your microservices and run them in a container in a containerized format. Now, Azure Service Fabric can be run in your local dev machine, which is super great. It can be run in Azure. It can be run in your on-premises environment or in other cloud providers as well. So you can run Service Fabric in all those different types of environments. Some of the features that the Azure Service Fabric offers for you are not limited to, for example, auto scaling. It could scale really to large number of instances. You have orchestration enabled. You have always on availability for your services so that those services never go into the idle mode. You have lifecycle management. You have DevOps and tooling enabling. You have health and monitoring and a whole bunch of different stuff that you get when you use this service. Now, folks, I'm not going to lie to you. Azure Service Fabric is not a silver lining, is not a silver bullet that you could say, whenever I want to run my microservices, Azure Service Fabric is the one for me. You need to analyze your requirement and try to make sure that you know what you're doing, because with greater responsibility, with greater power comes greater responsibility. So Azure Service Fabric is a really great service, but you need to have a really great knowledge to be able to run your containers or run your workload within the service efficiently. There are so many different places that this your deployments could go wrong. But again, if you know what you're doing, a really amazing service. If you wanted to, for example, have a look at the internals of the Service Fabric gives you a load balancer where you can load balance your workload within different types of, for example, nodes, whether you have your front-end nodes or back-end nodes, or however you have, for example, specified your workload to be running within this great service. It gives you integration with, for example, VNet. So you need to run the Service Fabric within VNet. You can run it outside of VNet, but again, you could expose those services to the outside world using all the other services that you already know. So Azure Firewall, you could have NSGs to limit the traffic incoming and outgoing. You can have, for example, rules to user-defined rules to create a custom routing from your hub and spoke topology, and a whole bunch of different stuff that is available. Some of the use cases when it comes to running your services within Azure Service Fabric, if you already have IaaS running applications within IaaS and you wanted to bring them into Azure, and you already have, for example, a Service Fabric environment running it within Azure, you could definitely leverage this amazing technology. If you already run Azure Service Fabric on your on-premises, again, you could convert those applications into containers and run them within the same environment. That gives you a lot of benefit because if you already have microservices running, these containers could easily talk to those microservices, or you can also have these containers talking to each other. You could prevent these to be public, so you can make them protected and give them private IP addresses, or you could expose them to other virtual networks within your environments or within your on-premises environment. So a really great way to run your workloads if you have those type of requirements. If you wanted to mix your containers and Service Fabric microservices, again, this is a great way for you to run your containers. Let's say you have an application which simply can be deployed as a single microservices within the Service Fabric. You could containerize that and run it as a container, and it leverages all the benefits that Service Fabric has to offer. If you have, for example,
just on that, Yas, just want to just confirm for me. So when we're talking about the Service Fabric microservice, we're talking about either the stateful, the stateless, or even the actor services, correct?
Yeah, so all of those, regardless of whether your services are stateful, whether they are stateless, or even the active services, when you deploy a container in there, you can communicate with all of those within your environment. So it gives you a unified environment where you have access to all of those by default.
Yeah, that's a good use case. I like that.
If you wanted to, so let's say you have a bunch of services which are very noisy. These are, for example, emitting a lot of events. They are producing a lot of noise in your environment. You could sort of reduce the impact of those by running in a container. In that case, that container could be really isolated. You could limit the amount of information coming out of that container and just run it and leverage that particular workload without impacting any other services in your environment. So these are a few different use cases for running your containers within microservices within the Azure Service Fabric, regardless of whether you have all your workloads as a container or you have a mix and match between your containers and microservices. This amazing service can really help with those sort of situations. Again, I don't have any particular demo for this one. But I will definitely looking up to be able to run Service Fabric locally. It requires a powerful machine, so I need to prepare some of the underlying infrastructure for myself before I can produce a demo. But I will definitely do that, and once I do it, I will record it and simply add these to these series. Right. I think it should be enough for this particular episode, George.
Yep. So I guess the only question I've got for you that I think everyone are probably thinking, and I hear all the time with AKS and Service Fabric, is what's the key difference between choosing moving containers into AKS versus Service Fabric? And now my assumption is that your Service Fabric containers are going to be .NET based versus not .NET based, or can you have .NET based in AKS as well? Any idea on how you position that with people that you're training?
Yeah, so there is a great .NET focus when it comes to Service Fabric, simply because Service Fabric was designed on top of the Microsoft tech stack. However, simply because you can run containers in the Service Fabric, that mystery is now busted. So it's really not a .NET heavy focus. Of course, when you're running microservices, that's the case. But now that you're converting those into containers, you can run it in any language you prefer. So it really doesn't make that much sense in that sort of comparison. The only thing that I can mention when it comes to preferring one of these services over the other is the type of orchestration that you have in mind.
Mm-hmm.
With the AKS, when you and we will cover that in our next episode. With the AKS, when you deploy your containers within the AKS cluster, you have the ability to, for example, run these at a mass scale. You have the ability to leverage other services if you run out of, for example, nodes, such as using the ACI or Azure Container Instances as a backup for your rapid bursting or any other sort of heavy containerized operations. With Kubernetes as well, you could definitely, if your requirements are forcing you or pushing you towards using a Kubernetes service, then AKS is much more preferred rather than microservices, because rather than Service Fabric, simply because you have to reinvent the wheel if you wanted to run the same within the Service Fabric. So you have to set up your Kubernetes cluster in there, and you have to manage it yourself and everything. AKS is a managed service, so you get all of that by default, and we manage a lot of stuff for you. We offload that responsibility from you so that you can simply focus on delivering values to your customers.
Okay. So you can actually have an AKS cluster within a Service Fabric. Is that what you
can definitely do that?
That's interesting. There you go. Well, there you go. That busts a few myths there. So, all right, yes, that was great. Hopefully everyone watching this gets a lot out of that. I know I can certainly talk about that to a different point the next time I teach an architecture course. So thank you for joining us for part 2 of this series. Join us for part 3 of this particular little series on containers in Azure, where Yas is literally going to go into detail about AKS, Azure Arc. I'm looking forward to that. Thanks, Yas, again.
Thanks, Stuart. See you in the next module.